In this question, we're asked to describe the end behavior of each of these polynomial functions. And to do that, we're going to use this format right here. And it reads, as x approaches negative infinity, f of x is approaching what? And we need to fill in this blank right here with something. And usually it's going to be either negative infinity or positive infinity in our cases here. And in other words, we could just say as our graph goes to the left, because our x's go towards negative infinity, that's going to our left. And then what is f of x doing? Well, that's what is our y doing? So is our graph going up or is it going down? And if it's going up, we'd say positive infinity. If it's going down, it'd be negative infinity. And then we say as x approaches positive infinity. So basically that's saying as our graph goes to the right, what is our y doing right here? Is it going up or is it going down? So let's start off with part A here, and if we want to figure out what the end behavior is and we know nothing about this topic, what I would recommend doing first is to plot this function on a graph. And I went ahead and used a calculator and already did this, and I had a graph that looked roughly like this. Okay, that's just a very rough sketch of it. Okay, now we want to follow this format. It says as x approaches negative infinity, so as our graph goes to the left, which direction is f of x approaching? So is it going up or is it going down? And as we go to the left, as our x values go lower and lower and lower, you could see that our graph is going downwards, right? Our graph's going downwards. So then our answer here is it's going down towards negative infinity. And then as our x's approach positive infinity, so as we go to the right, as our x's grow higher and higher and higher, what is the y's doing, or what are the y's doing? Well, f of x, it looks like the y's are going upwards right here, right? So we could say that that's going to be positive infinity. So as we went to the left, it was negative infinity. As we went to the right, it was positive infinity. And you could figure out what those answers are by looking at the degree, which is going to be 3 for this polynomial, as well as the leading coefficient, which is an invisible positive 1. But we'll get to that once we're done doing all these problems. So for part B, I graphed it in my calculator, got a nice graph, and I'm going to put down a very rough sketch from my calculator. So there's my sketch, and all that really matters is just the shape, to be honest. So let's go ahead and answer our questions here. As x approaches negative infinity, our y is approaching what? Well, as we're moving to our left, what's our y doing? Looks like it's going upwards, so we're going to say positive infinity. And then as we go to the right, what's our y doing? It's going downwards, so it's going to be going towards negative infinity. So I'll go ahead and put my symbols here. As we go to the left, it's positive infinity going up. As we go to the right, it's going towards negative infinity or downwards. On to part C, we're going to do again this same way. We're going to graph it in our graphing calculator, and I'm going to put down a rough sketch from that graphing calculator. And now I'm going to answer these questions. As x approaches negative infinity, so as our graph goes to the left, f of x is approaching, well, our graph is going upwards, so we could say it's approaching positive infinity. And then as x goes towards positive infinity, so as we're going to the right, our f of x is approaching positive infinity as well, because that one's going upwards too. So I'm going to say positive infinity and positive infinity. And then lastly we have part D, that's j of x, and I graphed it in my calculator, and here comes my rough sketch. And then I go back to my questions here, and we can ask ourselves, as x approaches negative infinity, so as we go to the left, what's our y doing? And it's going downwards towards negative infinity, so I could write that answer in there. And then as x approaches positive infinity, or as we go to the right, what is our y's doing? Well, looks like it's going down towards negative infinity as well, so this one's going to be the same. Now to come to all of our answers, what we did was graph it in the calculator and then I showed you guys the rough sketch. But you can also figure out the end behavior, whoops, by looking at the degree as well as the leading coefficient. So the degree of this polynomial right here was 3, this one was 3, and then this one was 4, and then this one was 2. So we have a degree of 3, 3, and then this was 4, and this was 2. Well, whenever you have an odd degree, the end behavior goes in different directions. So you could see for these two right here, part A and part B, the end behavior were going in opposite directions. But then for part C and part D, the end behavior was going the same direction, right? These were positive infinity, these were negative infinity. So whenever you have an odd degree, they go in opposite directions. An even degree, they go in the same direction. Now, how do you know which direction they go? Well, you look at the leading coefficient. So the leading coefficient for f of x is plus. And then this one, or not plus, but it's a plus sign or positive. And then this one right here for g of x, part B, it was negative. Well, think of it like this. Whenever you have a positive leading coefficient here, the end behavior is treated like a line with a positive slope, right? This orange line right here has a positive slope, but it also has the same end behavior, right? This one down here is going down towards negative infinity. This one up here is going up towards positive infinity. And then here we have negative, so if I draw a line with a negative slope, that end behavior again is the same direction, right? So you could treat it like that. Just think of a line with a positive slope or a line with a negative slope. For part C, we have a positive leading coefficient, so both end behaviors going upwards. And then part D right here, j of x, we have a negative leading coefficient, so that means that both end behaviors going downwards. So you have 4 possible scenarios. For odd degrees, they're going to go in opposite directions, and if it's a positive leading coefficient, it's treated like a line with a positive slope. If it's a negative leading coefficient, it's like a line with a negative slope. And then if it has an even degree but a positive leading coefficient, you've got them both going up. If it's a negative leading coefficient, both are going to go downwards.